Good morning, everybody. This is Kiran from Mechanical Engineering. Today, my subject is Thermal Engineering System. Here, we can observe that my topic is AI-based optimization of axial compressor blade design. Now, introduction to axial compressor blade design. Axial compressor are critical component in gases, turbines, and jet engines. Optimizing blade design enhance efficiency, performance, and durability. And AI means nothing but artificial intelligence offer innovation solutions for complex blade optimizations problems. And important of blade design optimization. Proper blade design reduce aerodynamic losses and improve fuel efficiency. Optimization accounts for multiple factors including flow dynamic and structural integrity. And AI driven methods uh, enable faster and more accurate design and iterations compared to traditional techniques. And overview of artificial intelligence in engineering. AI encompasses machine learning, deep learning, and evolutionary algorithm. These techniques can analyze large data sets to identify optimal design parameters. AI helps automated and accurate design process of complex engineering system. Challenges in axial compressor blade design. Designing blade involves balancing aerodynamic performance will in mechanical strength. Traditional methods are time consuming and rely heavy and expert intuition. High dimensional design space required advanced optimizations algorithm for effective exploration. Role of AI-based optimization techniques. AI algorithms can efficiently navigate large design space to find optimal solution, and techniques like genetic algorithms and a neural network facilitate multi-objective optimization. AI approach adapted to changing design, equipment, and operational conditions dynamically. At the same time, machine learning applications in blade design. Machine learning model predict aerodynamic performance based on geometry parameters, and surrogate models reduce computational cost associated with the CFD simulations. Data-driven insights, guides, and uh, iterative improvement of blade geometrics and at the last at the same time we can see that deep learning for shape and material optimization. Deep neural network optimize complex blade shapes considering multi criteria. This model can incorporate material and sorry for the disturbance and that material properties and structural construction seamless and deep learning enhance the capacity to discover innovation blade geometrically and evolutionary algorithm in blade optimization. Geometric algorithms mimic a neutral selection to evolve superior blade design, and they handle multi-objective optimization, balancing efficiency, strength, and manufacturability. Evaluated strategy explores unconventional and design solutions behind traditional methods. Hybrid AI approaches for superior optimization. Combining machine learning with evolutionary algorithm improves convenience speed and Shoegate model guide the search process, reducing reliance on expensive simulations. Hybrid method leverage the strength of multiple AI techniques for compressive solution and case studies and practical implementation. Recent studies demonstrate AI optimized blades achieving higher efficiency. Industry's applications include a turbine blade design for aerospace and power generation. Successful implementations showcase reduced design cycle time and improved performance metric and advantages of AI-based optimization. Accelerates the design process with faster convergence to optimal solutions. Enable explorations of a boarded design space for innovations configuration improves the robustness and adaptability of blade design under various operational conditions and limitations and challenges. AI models require substitutional high quality data for training and validation. ensuring the interpredictability of AI driven design and remains a challenge. Conceptually, resource and experts are necessary for implementing advanced AI techniques such as future direction in AI-driven blade design, integrating of real-time sensor data for adaptive blade optimizations in operation, development of a more explainable AI model to enhance trust and adoption, expansion of AI method to include multidisciplinary design optimizations of comprehensive solution. And conclusion, AI-based optimization significantly advanced axial compressor blade design capability and combining traditional engineering principle with AI techniques validates superior outcomes. Continued research and development will further unlock and potential of AI in turbo machinery design. This is the reference. Once we can see what we are discuss, what we the subtopics are there and what we discussed that. Here, what our topic is AI-based optimization of axial compressor blade design, and the introduction of axial compressor blade is nothing but it is a critical component like gas turbine and jet engine, and it have the high efficiency of that blade design because through the blade design only we can calculate the efficiency and durability of the gas turbine or any other components which is used. And in AI, we can see there is a one of the innovation solution, so through the innovation solution, we can calculate that problem of optimization. The importance of blade design optimization is it reduces the aerodynamic losses. That was one of the important. Another thing is it have multiple factors like low dynamic and structural integrity. This was the one of the important. And overview of AI in engine is nothing but there is a different type of AI. We know that, and that is machine learning and deep learning. These are the type of the AI. And challenges in axial compressor blade is mainly we can say that it have that the performance with the mechanical strength. That was one of the challenge, and it have the heavy expert time consumption will take place. Role of AI based optimization techniques nothing but it have the find optimal solutions. So that was one of the thing. At the same time, it have the genetic algorithm like neutral facilitate multi-objective optimization. Next, machine learning applications in Blade. Machine learning application mainly it has the reduce the uh, com computational cost. It have mainly we can reduce the cost. At the same time, it one more thing that was there. It have the aerodynamic performance based on the geometric parameters. And here we can see deep learning for shape and material optimization. For the shape, we can see that they consider the multi criteria, and mainly we can see for that is incorporate material properties for the better selection of material optimization. And evolutionary algorithm in blade optimization. It has superior blade. Through that blade, we can balance the handle and strength of and manufacturability. Hybrid AI approaches for superior optimization, nothing but it have the what we call it as in logarithm. Logarithm nothing but it's a step by step process. In algorithm, it improves the speed and convergence. At the same time, it have the model of guide such as process and reducing the reliance. Now, case studies and the practical implement in case studies mean nothing but it have the achievement higher efficiency. And one more thing is it, turbine blade design aerospace's power generation, and they can generate the power also at the same time through the case of the practical implementation. And advantages of AI means there is so much advantages, but here we can see that some of the better advantages that are optical solution means different solution for the applications. That one of the advantages. And other thing is that we can add or we can design a broader innovations configuration for the AI. And limitations is mainly limitation and challenges. Here limitation is it have the high quality data. That one of the limitation. And another thing is it interpretability AI driven design. And future direction in AI driven blade design is nothing but it have the adaptive blade optimizations in operation. At the same time, it have the enhanced trust and adaptable adoptions. This was the conclusion nothing but it have the finally the final that we can say that AI based optimization significantly advanced axial compressor blade design capability means nothing but it is it have that the type of source, and it have the ability to capable that blade of compressor At the same time, engineering principle with AI techniques yield superior outcomes. That was one of the thing. At the same time, it have the turbo machinery design because of the future. It will maybe in potential of artificial intelligence. That was the conclusion. This was a reference. We can say that. At the last way, I can say thank you.